Today's lesson is on acid nomenclature. In today's lesson, we're going to start off by defining an acid and what it means to be an acid. Secondly, once we've identified something to be an acid, we're going to show you how you can determine whether it is a binary or a ternary acid because they're named slightly differently. And then finally, we will show you how you can write the formulas from names and also the names from formulas as we've done in the other lessons. To start off, we must recognize that to be an acid, there's a couple things that has to happen. Number one is that it must contain the H plus ion. That means it's going to be an ionic type of compound with ionic bonds, and it's going to be done using the crisscross method. However, once it's dissolved in water, it behaves a little bit differently, so all of these must be dissolved in water. So for example, if we had H plus and Cl minus put together, if we crisscross those, according to the ionic naming system, that would be called hydrogen chloride. And that is actually correct when you put those two together. But once they dissociate in water, that is, dissolve in water, the name becomes a little bit different because of how it's going to behave, and we will call it an acid at that point. So we're going to name it slightly different, well, actually quite a bit different, than when we used ionic compounds. Now, when we have acids, there are two types. The first type is a binary acid. If you look at the name binary, it sounds similar to what we've been talking about all along. Binary basically is going to be two things. In this case, it's going to be the H plus ion, like we said, but it's also going to contain one other element off the periodic table, and only one other element. For example, we could put hydrogen and bromine together, and that would be an acid that's binary, or hydrogen with chlorine, or hydrogen with fluorine, but I'm not going to combine it with a polyatomic here. Now, if that is the case and we have an H in a single element, the name is going to be done by using the prefix of hydro. Hydro is going to indicate that the hydrogen is paired up with a single element. We're going to use the ending IC and then the word acid. So we're going to have hydro, some kind of root word, ic, acid. For example, if we put this together with bromine, or in particular the bromide ion, it would be hydrobromic acid. Or if it was chlorine, it would be hydrochloric acid. Okay, and so what we're seeing here is that we're going to use the prefix for hydro for binary acids, and then we're going to add the suffix IC to indicate that it's an acid, and then the word acid. The other type of acid that we can have is a ternary acid, and it's basically the same idea, except for hydrogen is no longer paired up with somebody off the periodic table, but rather one of your polyatomic ions. For example, chlorate or chlorite, or nitrate or nitrite. Now, because you have so many similar sounding names here, here's what they've decided to do. If the ending of the anion, or I'm sorry, of the polyatomic anion ended in ATE suffix, then we're going to change the ATE to IC. So what would happen is that if we had nitrate, it would become nitric acid. Notice I've dropped the prefix of hydro off because this is not a binary acid. Okay, if I had chlorate, it would be chloric acid. Now, you might say, well, then what do you do if you have the ITE suffix? Well, if you have the ITE suffix, what you do is you change the ending to OUS. So, for example, if I had chlorite, it would be chlorus acid. Or if I had nitrite, it would be nitrous acid. Okay, so what we see here is that to make the distinction between ATE and ITE, we use different suffixes for the ternary acids. Also, again, please notice that I did not use the hydro prefix here. Okay, I'm back at my simulation that I've been using for all the other lessons. And what we're going to show you here is basically how you come up with the formulas and the names. So what we will see here is that if you looked on the periodic table for hydrogen, hydrogen likes to form a +1 charge. So we have an H plus here. Now, because of the rules of ionic bonding, it is looking for basically one negative charge to help cancel out this positive charge. So, for example, it may pair up with fluorine with a minus charge. If this happens, we see that the charges have canceled out. We have H and F. Okay, our formula would then be HF. Okay, and the name, based off of our rules of acids, is going to be, because we're using a single anion off the periodic table, we must use the word or the prefix hydro. We must then use the root word, which is fluor, and then we add the ending IC. So this would be hydrofluoric, and then we always put the word acid here. So what we see here is that this guy would be called hydrofluoric acid. Hydrogen, again, because of the second element here being only a single element off the periodic table. HF would be the formula because it's one of each. and the name is again hydrofluoric acid. All right, now, after we've named this, we can move it out of our way, and we'll look at a couple others real fast. If we take H plus again, and I this time pair it up with SO3. SO3 is sulfite. Sulfite has a -2 charge. That means when I try to put these guys together, I'm going to need another H to help cancel out the two negatives of sulfite. So I bring an H down here, and what we see is that I needed two H's to do this. So now I have H2SO3. Okay, this is actually written wrong, so I'm going to fix this real quick. It's not H2SO4. It is H2SO3. My subscript's a little bit off, so I'll fix that real fast. Okay, and we see that this H2SO3, when we try to name this, we have to look at the name of the polyatomic ion that was paired up with it. So notice that it is polyatomic, so I don't use hydro anymore. I use the root word sulfur here. Okay, sometimes we would use sulf, but it sounds better to call it sulfur here. And because sulfite was used, the ending ITE is changed to OUS rather than IC. So this would be sulfurous acid. Again, notice that when I did this, I did not use the prefix hydro because this was polyatomic. And I used the root word of sulfur and added OUS because it was sulfite. So again, this is sulfurous acid because of our naming rules. Okay, our final one that we'll look at here will be if I decide to pair hydrogen with PO4. Okay, PO4 is phosphate. So what we have here is I have an H, but I see that I still need more H's in order to satisfy the PO4. So I bring a second one over and yet another one. So now I have three H's for this PO4. Everybody looks like they're good here. So what we will see is I've used H3PO4. Okay, three H's and one PO4. So my formula, again, H3PO4. Now, again, what I notice is that this was a polyatomic, so I do not use the hydro prefix. I just take the root word, which is phosphor. Now, this was phosphate. Now, I have to decide whether I'm going to be using OUS or IC ending here. Now, because it was phosphate, remember that we changed ATE to IC. Now, a little way that one person said it in class, and it kind of works for some people, not always for everybody. But if you want to try to remember, the rule is adic-itis. It sounds kind of like a weird disease. What we mean is that if you end in ATE, you should change to IC. If you end in ITE, you should change to OUS. So again, adic-itis. So this would be phosphoric, and then we always add the ending of acid to it because acid indicates that H was in the front. So we have phosphoric acid. So we've shown you basically how to name all of these different acids, and now what we're going to do is go back and just show you how you would read an acid. All right, our final slide here is just kind of a summary of what we were just explaining. We're going to show you how you write the names from formulas. Now, if you notice here, I'm actually trying to show you the rationale for why we need to name them the way we do. For example, if we had HCl, the first thing we recognize is that because H is in the front, it will have the name acid, so we put the word acid here. We also notice that the H is paired up with just a single element, so this is going to be chlorine. So we're going to pair it with the word, or the prefix, I'm sorry, of hydrochloric acid, meaning that it is hydrogen and one single element. Now, where this becomes important is because if you look at this guy, this is H paired with a Cl, but also with O3. ClO3 is actually the name of chlorate. So we don't want to use hydro because if we call it hydrochloric acid, now we have two different things that have the same name. So we drop the hydro off because it's not a single element, it's polyatomic. So we call it chlor. And because the ending used to be ATE, we change it to IC. So this would be chlor, if you see in red, ic acid, chloric acid. The acid indicates H. The chloric indicates that it was paired with chlorate. Okay, you might say, why not chlorate acid? Well, I don't know, but that's what they chose to do. So it's chloric acid. Okay, we also have HCl, HClO2. ClO2 is chlorite. Now, again, we can't call it chloric acid because chloric acid is this guy, and they're not the same thing. So they decided, again, that if it ended in ITE, we use OUS at the end. So this would be chlorous acid or chlorous acid. No hydro because, again, it's polyatomic. All right. So what we've done here is we've basically shown you all the different things you need to know about an acid, Please make sure that you take the online quiz that goes with this lesson, and be sure to bring your questions with you to class so that we can discuss any difficulties that you may be having.